Howdy, this tutorial video is going to walk you through another example of solving a systems of equations by the substitution method. So yesterday in class we learned that substitution means to replace. So what we're doing a lot of in these kind of examples is replacing different variables with values, right, or an expression. So some of you yesterday just depends on what class. Some of you, this is going to be example 2. Some of you, this is example 3, and I know my third period we got through half of an example, I believe. So just give some room so we can finish that example when I am back. So this goes straight in your notes, just under where we finished yesterday, and just label it example number blank, whatever it is for your class. Okay, so I have a systems of equations here, and what I can do, well, first of all, I know it's a systems of equations because it has this bracket that groups them together. And what I want to do is I want to figure out the solution. So we know that the solution is the ordered pair where they cross each other. So we know the solution is going to end up looking like this. So we need to actually find the x value and we need to actually find the y value for this systems of equations. Okay, so we're going to do that. We could graph this, we could figure out where they cross, and then that would be the solution. And that would work, except if they don't cross straight on a grid line, it's really hard to tell. And so we are going to use what's called the substitution method. Okay, so the first thing you're going to do, and this is straight out of your notes yesterday, if you don't have your notes, you can look in Canvas, but the first thing we're going to do is set either equation equal to one of the variables. So in this system, we have the variable x and we have the variable y. So our job is to get one of the equations, it doesn't matter which one, equal to either x or to y. So I noticed that the bottom equation, it already is equal to x. X is by itself. So guess what? Step 1 is done. Step 2 is that we're going to take this equation and we're going to plug it in to the other equation. How do we do that? We are going to take, let me see if I can find the highlighter tool. Here we go. We are going to take what x equals. This is the expression. Does that really highlight it? No. So let's try that again. Here we go. We're going to take what x equals. So the expression that x is 3y plus 6. And anywhere in the other equation that we see an x, we can plug in that expression instead. Why are we doing that? Well, we want the x to go away, right? And the reason for that is we cannot actually solve this solution unless we only have one variable. So basically what we're doing is we're substituting, we're replacing, so that once we replace or we substitute, we're only left with one variable. So let's see how that looks. Instead of x, I'm going to plug in what x was equal to, 3y plus 6. And then I'm just writing the rest of the equation. Okay, I'm going to distribute. So once you get here, you can see that the only variable we have left is a y. So now once we're here, we're just solving for y. So here we go. 3 times 3 is 9y, and 3 times 6 is 18. Just copying the rest down. And then I have some like terms. I have a 9y and I have a 3y, so I can combine them to make 12y. And then once we get here, all the y's are together, and now we need to get rid of those numbers, the 12 and the 18. I'm going to get rid of the 18 first. It was being added, so the opposite of that is subtracting. This cancels out right there. And we are left with 12y equals 18. can divide both sides by 12 to get rid of that 12. This is going to cancel. Sorry. And then 18 divided by 12 is 1.5. So it's a really great idea that I didn't decide to graph this, because how would I have known if it was 1.5 or 1.49 or 1.48, right? Those are all very close together, 1.6. And so the fact that I solved it using the substitution method just means my answer is 100% accurate. Okay, so now I've solved it. So now what I'm going to do is I'm going to take this value of y and I'm going to plug it into either equation. And it doesn't matter which one, just your personal choice. I noticed that this bottom equation is already set to x equals, right? We talked about that before. If I know the value of y, then now I must be looking for the other one. I must be looking for the value of x. So I'm going to use that bottom equation. If that's like too much for you to think about, or you're not there yet, just pick an equation, okay? And we know that instead of y, we can plug in 1.5, right? There's substitutions of each other. Okay. And once we get here, we just get to solve. So 3 times 1.5 is 4.5. And then we're going to add 6 to that, which is going to give us 10.5. Yay! We're done? Question mark? Are we done? No, because what does it say in our notes? We have to write our answer as an ordered pair. If you are paying attention still, put a smiley face at the top right corner of your notes, and you're going to show me tomorrow. Okay, so we have our ordered pair. So this is where, like, technically we are done, right? We have the solution, but this is where you could go a little bit further. And it's a really great idea to go a little bit further. We can actually check, is that solution correct? So how do we do that? We take both equations. I'm going to leave space between them. And in both equations, we can plug in both the x and the y value. Three times 10.5 is 31.5. And 3 times 1.5 is 4.5. And if we add those together, we get 36, which is what we wanted. So it's great. But we actually have to check with both equations. It can't just work with one, it has to work with both. So I'm going to plug in my x and my y again. Three times 1.5 is 4.5. And 4.5 plus 6 is 10.5. So it checks out, it works, I am done. So the solution to this equation is what we have up here, 10.5, comma 1.5.